Hello, good day, family out there. Today, too, you are welcome to Sir Urban's online tutorials. Now, today I present to you the part two of factorization, still under type 1 factorization. Over here, we are still going to dive into how to factorize expressions involving two terms. Now, I am here to expose you to using another idea in mathematics in factorization. And the idea is called expansion method. So let's use the idea of expansion method to factorize expressions involving two terms. So I am here and I want to teach you how to use the idea of expansion method to factorize expressions involving two terms. Afterwards, when there is more time, I will help you throughout expressions involving three things. So come closer and let us learn another way or an easy way which I think it will help you to factorize expressions easily. Very good. So let's come here. We have algebra, that is factorization. That is, we are going to look at type 1 factorization. We are referring that to expressions involving what? Two terms. So question number one, I have 10x cubed y squared minus 25x power 4 y. Now, we all agree to the fact that when we want to factorize this, which is this expression involving two terms, the first thing that we are supposed to do is to find for the common terms. Are you with me? So we factorize the common term out, and then the uncommon terms or the term that will be left behind, we place them in the brackets. But my discovery that I've done is sometimes you didn't find it challenging using that approach. So I am going to expose you to the approach which involves the use of what? The expansion method. So the expansion method is what it states. Now, we have a whole number thing here. So using the expansion method, the idea is we have to make sure that we find for the factors of the whole number thing here, which are prime numbers. So let me start with the number thing. If I go to the number thing here, and I want to find the factors of them which are prime numbers, it means I'm going to list down two numbers that if I multiply, I'll get what 2 and 5. Are you with me? And you realize that 2 is a prime number, 5 is also a prime number. So therefore, I can bracket this. So my first approach, I can bracket this as 2, and then I can have 5 here. That means when we multiply 2 by 5, we are going to get what? 10. Are you with me? Very good. So let's continue with the other part. Now we have x power 3 multiplying them. Now the x power 3 here mathematically can be expressed as x multiplying another x multiplying another one x. I believe you are clear with that. Let me reduce the tail of the y so that you will not get confused. So the tail of the y, let me write it well so that you will not get confused. Alright. So mathematically, if I multiply, we all agree to the fact that when you multiply x by x by x, you are going to get what? X power 3. The same manner when you multiply 2 by 5, you are going to get what? 10. And the bracket there over there means what? Multiplication. In the same manner, the y squared over there can be written as y multiplying another y. So mathematically here I can express the y squared, the y power 2 as y in one bracket, then y in another bracket. This I believe you are following. Very good. So here too, let me write the y was so that you will not get confused. So I'm done expanding the first part or the first term within the expression. Are you getting me? Now let's go to the second part, which is the second term within that expression. The same manner, the whole number there is 25. So I have to make sure that I identify the factors of the number 25, which are prime numbers. Now I have the number 25 here. So identifying the factors I have here to be 5, here to be 5. So all these are prime numbers. So here the 25 can be rewritten as 5 in a bracket multiplying another 5 in another bracket. I believe you are clear with that. Very good. And then the x power 4 can be expressed as x multiplying another x multiplying another x multiplying another x, then multiplying y. I believe you are clear with that. So x times x times x times x will give us x power 4 multiplying y. So this is what we call the expansion method. We are expanding each of the variable and then the numbers over there. Are you clear with that? Very good. Now our next approach is we are going to identify what we call the common terms. So let's look at how to identify the common terms here. So what we are going to do is we check from this side and then this side. Okay, if a number is here or a variable is here that is available here, we cancel it out and we accept it as a common term. So let's come in. Let's check if we have 2 here, there's no 2 there. Are you getting me? There's 5 here, there's 5 there. So 5 is here and then 5 is there. So I've gotten one of the common term, which is 5. So the common term 5 will come out here. I have next one, which is x is here, there's x also here. So x is here, there's another x. So x becomes another common term. I believe you are following the concept. Good. So I have another x here, there's another x there. So x comes out, then I have another x also here. So it means I have another x as a common term. The same as I have x here, x is also there. So x is there, and then I have another x here too, which becomes another common term. Alright, so we continue with the next part. Now here I have y, there's another y here. So y goes with this one. So it means I have another y as a common term. Now let's check again. There's y here. Do I have any other y left here? No. So that means we are then identifying the common terms or the terms that are available here and then here at the same time. We are done with that. Now the terms that are left here in the first term, okay, and the second term that are left also, we are going to put them in a bracket. So I'll open my big bracket, and then let's come here. Let's start with this place first. Which means I'm going to multiply all what I have left over there. Remember, here is left with 1, here 2 is left with 1, here 2 is left with 1, here is left with 1, here 2 is left with 1. I believe you are clear with that. Very good. And here is left with y. So what I'm going to do is I'm just going to multiply through. 2 times 1 is 2 times 2. Sorry, times 1 is 2 times 1 is 2 times 1 is 2 times 1 is 2 times y gives me what? 2y. Alright, so here I'm getting 2y minus, then here is the minus, so I'll come to this side also. Over here I have 1 left, I have 5, here is 1, so I'm going to multiply. 1 times 5 is 5, times 1 is 5, times 1 is 5, times 1 is 5, times x is 5x, times 1 is what? 5x. So I have 5x also left. Okay, so now let's continue with the process. My next then is, I believe you are following the concept. So the 2y was left there, here, okay, and then 5x was left here. Are you getting me? So this becomes the uncommon terms. Now my next approach is I'm just going to multiply what I have here. So multiplying that, 5 multiplying x is 5x, multiplying this 5x squared, multiplying this is 5x cubed, multiplying this is 5x cubed y. So I'm getting 5x power 3 y, then my this and I have it in a bracket, 2y minus 5x. So this then becomes my answer. I am done factorizing the expression 10x cubed y squared minus 25x power 4y. So this is the idea of expanded method or expansion approach. Okay, so I wanted to use this approach to help students out there who find it difficult in factorizing expressions, and I believe with this you'll be able to factorize any other expression given to you. So we are testing it with expressions involving 2 terms, and we believe that at the end of the day, when you find it interesting, you can share it among your colleagues also who are out there, so that they will also benefit. Likewise, you are benefiting. So let's dive into question number 2. All right. Okay, so in the same manner, when we dive into question number 2, we have the expression 100x minus 25x squared. Okay, so 100x minus 25x power 2. So this one we are going to use the expansion method. Remember, I told you the expansion method simply means we are splitting the terms that we have in the expression one after the other. And I believe when you understand this word, you'll be able to solve whichever the expression that you'll be given to factorize. So let's see what is happening here. We are going to identify the factors of hundreds which are prime numbers. So here I have 10 here and then 10 there. Okay, now 10 is not a prime number, so I can split it out to get 2 and 5. Here too I can get 2 and 5. And we all know that 2 is a prime number, 5 is also a prime number. So here the 100 can be split as 2 multiplying another 2, multiplying another 5, multiplying another 5. Then multiplying. Okay. Alright, so we continue with the process. So 2 multiplying 2 multiplying 5 multiplying x at the same time. So please, let's continue. Right, so we are now expanding the first thing within the expression. I get it. Now let's come to the second thing within the same expression. So my minus sign will come, or my negative sign will come. Then I will take the 25 also is not a prime number. So definitely I will split the 25 into some factors which are prime numbers. So I'll have 5 here, 5 there. So it means that with the 25 I'm going to get what, 5 here and then 5 there. The same manner when I get to the number x, the x here, okay, the x squared can be expressed as x multiplying another x. And we all know that x times x will give us what, x squared. You know that. So in mathematics, when you have x multiplying another x, you know that x, this is the same as x times what, x. And here the power is 1, 1. So I'm just going to add the powers, which is 1 plus 1, which gives me what, x power 2. I believe you are clear with that. Very good. So this is the same as this. So now that we are done expanding or splitting it up, we are now going to identify what we call like terms. Very good. So let's continue with like. So here, the like term here, I have 2 here, there's no 2 there. Okay, 2 is here, there's no 2 there. So 5 is here, 5 is there. So I can get rid of that. And I will identify it as my common third. The same manner, when we come to this side, I have 5 here, 5 there. So I will identify this as my common third. I believe you are clear with that. Very good. So the same manner, if I come here, I have x here, there's x here too. So I'll identify this as my common third. Are you clear with that? Very good. So let me write this x well so that you will see it well and then you will enjoy the lesson. Okay, so I am done identifying the common terms. Now I will open my big bracket and I will indicate the uncommon terms over there. So let's come here and identify the uncommon terms. We have 2 times 2, which is 4, times 1, which is 4, times 1, which is 4, times 1, which is what? 4. So it means over here, the term left, which is an uncommon term, is 4. Minus, this is my minus sign. Now come to this side also. So I'm going to multiply. 1 times 1 is 1 times 1 is 1 times x is what, 1x. But we all know that x is the same as 1x. So our next step, which gives us our final result, we are going to multiply this, which is 5 times 5 is what, 25 times x is 25x. So here I have 25x in a bracket, 4 minus x. So over here I can leave this as my final answer. It means I am getting this as my final answer. Mathematically, when you use this to expand, you are going to get this one back. And if you get it back, it means your result matches with a factorization. This then becomes our final answer. And I believe you are clear with that. Very good. So now we can quickly dive into question number 3. So question number 3, you see we have some fraction over there. Some students are asking themselves, wow, how can we go about this question? Don't worry, it is easy. Don't worry yourself, relax, and let us cope together. I want to give you some few minutes. You glance through how question number 2 was solved. Then after, I'll get back to you with question number 3. Okay, so let's continue with live. Please do not forget that if you find this video interesting, you comment, you like, and then you share. Do not forget to subscribe because we are here to help students out there who find problems in mathematics and they think that problem is out of, it is too much for them to solve. We are here to help you out. So if you encounter any problem, make sure you bring it on board and we discuss it for you. Thank you very much. So let's dive into the next part of the factorization problem, which is question number 3. There are fractions over there. Don't be scared. We will help you out, okay? Very good. So question number 3. Question number 3. I have 1 out of 4 bx squared plus 1/8 bx. So the expression 1 out of 4 bx squared plus 1/8 bx. So this one also we are going to factorize. I get it, me. That's why I said do not be afraid. We are still using the expansion approach. And let's see how we're going to use that expansion approach to solve that. Now, you know that mathematically 1 out of 4 can be expanded. You see, the 4 can be expanded as 2, where 2 is a prime number, 2 here, 2 is a prime number. Now that it is a fraction, I can express this one as 1 out of 2 multiplying 1 out of 2. And mathematically, when we multiply this, you see, when we multiply 1 out of 2 by 1 out of 2, okay, we are going to get 1 times 1 is 1 over 2 times 2 is 4. So we are getting this as we have here. Are you getting me? Very good. So mathematically, it means that this can be expressed as 1 out of 2 multiplying another 1 out of 2. And the bracket over there means multiplication. So in the same way, if I come here, it means that I'm done expanding the fraction 1/4, and I'm getting half times half. I believe you are getting that. Very good. So here I'm getting 1 out of 2 multiplying another 1 out of 2. Okay. Then I'll continue with the next part. Now remember there is p, the variable p attached to it. So p is also multiplying. I have x multiplying another x also multiplying. Let me write this x more so that we can all follow and then move on with life. Very good. So let's dive into the next part. Now I am done expanding the first term within the same expression. So this expression has 2 terms. The first term is 1/4 bx squared, and I'm done expanding it. Remember, when we multiply this, we are going to get 1/4 bx squared. Alright, so let's come to the second term of the same expression. Now I have 1 out of 8. 1 out of 8 can be expressed. You see, the number 8, I can express this one as 2 by 4, which gives me 2, 2. So these are the prime numbers over there. So mathematically, this can be expressed as 1 out of 2 multiplying 1 out of 2 multiplying 1 out of 2. I get it. This one means that when we have 1 out of 2 multiplying 1 out of 2 multiplying 1 out of 2. Okay, so we know that 1 times 1 is 1 times 1 is what? 1. So I'm getting 1 over, let's multiply this. 2 times 2 is 4 times 2 is what? 8. So mathematically it means that half times half times half gives us what? 1/8. I get it. Very good. So here you can express the 1/8 as half multiplying another half multiplying another half, and then the p will get in, and then the x2 will get in. I believe you are following the concept. Very good. It is not difficult using the expansion approach. Using the expansion approach, I think it will help a lot of students to get the concept. It will help a lot of students to understand and get the idea of what you call common terms. So we are going to sort out the common terms over there. So here you can see that I have half over there. Here too there is half. So half becomes the first common term. There is another half here. Another half here is also there. So we've gotten another common term over there. Let me clean this one from there so that it will not confuse us. We continue with the procedure. So here I have p here, there's another p. So p is here, there is another p here too. So I will select p as another common term. We continue with the process. So here there's x here, there's x here too. So x becomes another common term. It seems we are done with a common term. X is here, there is no more, we don't have any other x left here. Alright, so we are done identifying the common term. So we open our big bracket, then we are going to write down the uncommon terms. Remember here it's left with 1. So 1 times 1 is 1 times 1 is 1 times 1 is 1 times x. Gives us what? 1x. Alright. Remember here was 18px. Let me write it up here so that it will not confuse you. So that you will think that it is part of no. So here was 1. Okay, so after multiplying 1 times 1 is 1 times 1 is 1 times 1 is 1 times x is 1x. So I will rewrite it as this. Okay, 1x is the same as x. I believe we agree with that. Very good. So plus, now when we come here, yes, let's with 1. So 1 times 1 is 1 times half. Gives us half times 1 is half times 1 is what? Half. I believe we agree with that. Very good. Now, someone is asking, how come 1 times half is half? So let's see. 1 times half. Okay, this is a whole number. It has a denominator of 1. It is 1 times half. And the 1 here is a whole number, so it has a denominator of 1. According to the rules of whole numbers, the idea of whole numbers. So here when we multiply, 1 times 1 gives us 1 over 1 times 2 gives us what? 2. That's why we say 1 times 1 is 1 times half is what? Half. So half here becomes an uncommon term. So we are done listing down both the common terms and then the uncommon terms. Please, I believe you are getting the process and it's very, very interesting, right? Very good. So let's proceed with the next approach. So over here, we are going to multiply the common terms here, where we have 1 out of 2 multiplying another 1 out of 2. I'm talking about this. So here, when we come here, 1 times 1 gives us 1 over 2 times 2 gives us what? 4. So here we are getting 1 out of 4. Then here to multiply this by that. So we are getting what? Px. Are you following? Let me write it well. Here we took this and then we had 1 out of 4. That's, and here to be multiplied, so we are getting px. Let me write it this in well. So I'll open my big bracket. I'm getting x plus half. So that's what I'm getting. I am not done. Let me conclude my final answer, or let me conclude my answer well, so that you understand the procedure. My final answer, if I multiply this, I'm going to get 1 out of 4 px. And I'll open my big bracket, this one, x plus 1 out of 2. So this is what we are getting. So you see that using the exponential approach becomes easy. I get me. So I will advise you to expose these videos to your colleagues out there so that they will also enjoy a great day. They will enjoy, they will feel the real nature of mathematics, and they will always embrace mathematics with a good heart. Let's continue with the last question. But I believe after going through with you, going through question number 1 with you, question number 2, question number 3, you'll be able to solve question number 4 on your own, right? Alright, so I'll give you a few minutes to glance through this, then after we dive into question number 4. Okay, so let's continue with question number 4. Alright, so question number 4, I have the expression to be negative 15x plus 6. Negative 15x plus 6. This one, someone is asking, how come this is negative 15? How can we do it? Don't worry. Don't worry, it is easy, right? It is easy. Remember this. Let me open your eyes a bit. Can I ask you this question that when we have this negative 2 plus 1 in maths, you see, this is the same as 1 minus 2. Do you agree? This is the same as this. Do you agree with that? Yes, it's the same as this. Because 1 minus 2 gives us what? Negative 1, and this also gives us what? Negative 1. So they are the same.
Are you with me? Very good. So in the same manner, if we have negative 2x plus 1, this mathematically is the same as 1 minus 2x. So this expression is the same as that. Now, why am I exposing you to this? I want to let you know that if you have a negative sign here and you are confused, then it means that you can switch the negative 15x to the other side so that you feel comfortable. I know why you are confused. You are confused because over here there's no negative, here there's no negative, here there's no negative. So how come here we have a negative sign? Don't worry, that is why I'm trying to explain to you that if we have something like this, the same as this. So mathematically, if you are confused, then you can decide to turn this one the other way around. So this can be rewritten as 6 minus 15x. I believe now that it looks like this, you are okay, so you can easily factorize, right? Very good. So now, I don't want to use this, but I want to show you how we can factorize this as it is without rewriting it of the form this. Please have it in mind that when you try to rewrite it of the form this and you expand and factorize, you get the same answer as mine. So let's continue with this. Now, we know that negative 2x in math can be expressed as negative 1 multiplying 2 multiplying 1 x. Do you agree with this? Yes, you agree, right? Negative 1 times 2 gives us negative 2 times x gives us negative 2x. I get it. So in the same manner, when I come here, I can rewrite this one as negative 1 in the bracket 15 in the bracket x. I get it plus 6 in another bracket. Are you following the concept? Very good. Let me write my x well so that you will also see it well and enjoy the lesson. Now 15, the number 15 is not a prime number, so I have to split it down. I'm going to get 3 and 5. So 3 is a prime number, 5 is also a prime number. 6 also I have to split it because it is not a prime number. I'm going to get 2 and then what 3. So here I have negative 1, I have 3 there, then I have 5, then I have x, then plus, I'll come here 2, and then what 3. Let me write my 3 word. Okay, so we continue with the next approach. I believe you are following the concept and you are enjoying how it goes. Now you are, I believe you are there, you are happy because you now know how to find for the common terms easily, right? So now we are done expanding it. What we are going to do next is we are going to identify our common terms. So when we come here, there's negative 1 here, there's no negative 1 there. So we have 3 there, and there's another 3 here. So 3 comes out as a common term. There's 5 here, there's no 5. There's x here, there's no x. So I'm done identifying the common terms. Now I'll open my big bracket, and then I will go ahead writing down the uncommon terms over here. So let's come here. What terms are left? I have negative 1. Multiplying this is negative 1. Multiplying this is negative 5. Multiplying this is negative 5x. So I have negative 5x here. Then plus, okay, so plus this. So plus 2 multiplying 1, I'm going to get what? 2. Then I open my big bracket. So now my final answer becomes 3 in a bracket negative 5. So negative 5x plus 2. This then becomes my final answer. Or mathematically, this can be rewritten as 3 in a bracket 2 minus 5x. And I have not changed anything. It is still the same as it is. So this and this are the same. Thank you very much, my fellow students. I believe you enjoyed today's lesson also, and everything moved on smoothly as it's supposed to be. And I believe you've gotten another way or another approach in factorizing expressions. Now today we've been able to dive into expressions involving 2 terms. Our next meeting we will definitely dive into expressions involving 3 terms. Then the next meeting will be expression involving 4 terms. Then we dive into quadratic trinomial. Thank you for your time and thank you for staying tuned. Have a wonderful day. I will advise you that, and I will encourage you again that if you find this video interesting and helpful, please do not forget to subscribe. Okay,
and make sure you share it among your colleagues out there too, because they also need help as you are also in need of it. And now, if you find this video helpful, make sure that you share it with them so that they will also be redeemed from their problems. Thank you and have a blessed day.